2015 connected particles question. This question, we were given this diagram and we were told two particles P and Q of mass 4 kilos and 7 kilos, 4 kilos and 7 kilos, are lying 0.5 meters apart. So this distance here is 0.5. And they're connected by a string 3.5 meters long. So just write that up here, 3.5 meters for this string that's not taut. Q is 6 meters from the edge of the table, 6 meters in here to the edge of the table. And it's connected to a particle R, which is of mass 3 kilos. And it's hanging freely by a taut, light, inextensible string passing over a light, smooth pulley. The system is released from rest. Find firstly the initial acceleration of Q and R. So we do diagrams for Q and R. Let's look at R here first. So we have 3G going down. We have this string going up. And if we imagine this table like frictionless light, that the Q is going to slide along to the edge of the table, we have R going down with an acceleration A. And Q is going along the vertical. So let's have a look at Q. What's going on here? Well, we have this string, this taut string, so T going in that way. That's the only force happening so far. There is a string going in this way, but it's not taut yet. So the forces equations from F is equal to ma is going to be 3G minus T is equal to 3A. And in this one, we're just going to have T is the only force, and that's going to be equal to 7A. Q is 7 kilograms. So if we write this one up here, 3G minus T is equal to 3A. We're going to get 3G is equal to 10A. So A, the initial acceleration, is 3G over 10. We can leave it like that for now. Part 2 of this question, the initial speed, the speed of Q when it has moved 3 meters. So the speed, we want V, we have S is 3, we have A, we just got as 3G over 10, and the system was released from rest. So we're going to use this really common equation, V squared is equal to U squared plus 2AS. So we're looking for V. So we can put in our 0 if we want, plus twice 3 by 3G over 10. So that's going to give V squared to be string was 3.5 and in part 2 Q had moved 3, so P is about to begin to move. So I think the principle of conservation of momentum will work best here. we know that R and Q are moving with the same acceleration, and their mass is 10. The mass of P is 4. So our principles of conservation of momentum, M1 U1 plus M2 U2 is equal to, and we'll see this more commonly used in impacts and collisions, this is equal to M1 V1 plus M2 V2. Now these two, it's going to be moving at the same speed, so these V's are the same. So this is the V that we're looking for, the speed which P begins to move. So let's write out what variables we have. V is equal to V. We have M1 is equal to 10, combination of R and Q. U1 is equal to the speed at which Q is moving, this one here, 4.2, so U1. And we also have, well, that's all we have, so we can fill these in. So we have 10 by 4.2 plus 4, starts from rest, 0 is equal to 10 V plus 4V, because these speeds will be the same. So on the left we have 42 is equal to 14V. This works out evenly. You can see 42 divided by 14 is 3. So 3 ms to the minus 1 is the speed with which P begins to move.